Hey everyone, I'm Patrick Heinen. I was basically tasked with coming up how we stitch all this together with Gawain. And so first we looked into traditional panorama stitching, the way you would do it for your HDRs that you shot on set, or the way anyone who has ever taken a panorama stitched their panorama. The difference being though that if you stitch a panorama for a still, you have your camera and you just rotate it around your nodal point, and then you can just align your different images with feature points and everything's gonna look amazing. However, as we had to shoot everything at the same time, we couldn't get all our 4 cameras with the nodal point in the same physical position. So what you end up with is parallax, and I'm pretty sure most of you are aware of this, but it's always good to remind yourself a little bit how big that effect actually is. And I'd like to hold up my finger and look at it with one eye and the other eye, and it's quite a big effect that it has. You'll see the background jumping left and right, and that's basically what we're battling here. We want to align 2 images, but on one image the foreground object's on the left of my background object, and on the other camera's image my object's going to be on the right of the background image. So there is really no easy way to just line those images up in 2D. You're constantly battling parallax. So we first looked into this, but quickly abandoned the idea of doing a 2D stitch and moved into more 3D based, spatially correct stitch, which also had a huge implication further down the line, because we knew we were going to have quite extensive CG environments and visual effects in this piece, so we needed to make sure that what we rendered would sit into our stitch and track with our stitch. So that's why we based our stitch on a physical world, and with that then we're safe to just drop our spherical render into that stitch and everything would line up and not drift away. So the way we stitched it is that the theory behind it is that we simply took all 4 cameras, projected them out onto geometry, and filmed it back from one spherical, perfectly nodal spherical camera. For this to work though, you need quite a few elements, and precision in this case is key. So we had our geometry was LiDAR scan geometry from the set. Then we used that to track our cameras, so that our camera tracks would solidly line up with our geometry. And one other point is what Wayne mentioned. As we use fisheye lenses that have a very different geometry to your standard rectilinear lens, we had to precisely understand that lens geometry to make the track work and then the projections work. So it was really these 3 points, pretty precise geometry, track, and lens undistortion, that we needed to be spot on for the projection approach to work. So then for people, obviously we didn't have LiDAR scan, real-time scan. We looked into it, but it probably wouldn't have given us the desired result anyway. So we abandoned it and started projecting people on cards instead. So we tracked cards in 3D space to line it up with their ground contact, and then projected onto cards for people, which worked really well. So in theory, that all sounds really cool. You just project it out, film it back, and it's perfectly stitched. However, parallax strikes again. What you quickly forget is in order to film it back from one central point, you're changing your perspective again. So you project out from here, but you're going to film it back from here. So all of a sudden, you're going to reveal areas that you didn't actually film, which these 3 little cubes are trying to visualize. So you see that you have an area that you didn't capture that you now need to fill in. So that was one of the big manual labor works, basically, was painting in areas that we didn't capture. And in order to minimize that work, we came back to our hero camera concept. So we had our hero, the position of our spherical, perfectly nodal camera was always at the position of one of our 4 cameras, which allowed us to not have to do this whole projection spectacle for all 4 cameras, but our main action could just stay the plate how it was, and we didn't have to do any work to it. Having to paint things in, we had to basically separate out every depth layer, rebuild every depth layer by itself through projection and painting in. And we also realized that at your geometry edges, if you just project on precise geometry, it's never going to be exactly how your plate was. So you'll have, sometimes your geometry is going to be a little too small, or there's too much detail and your geometry edge is going to be too hard. So the edges you would get are like on that car, you see it's kind of, it's hard to see on this big screen, but the edge you would get was pretty hard and not what you had actually photographed. So in order to avoid that, we started using a mix of different geometry to project on for more complex shapes. So we ended up using what we call blob geometry. So it was basically a soft approximation that was slightly bigger that we could project on and then cut it out with our rotor, which would give us nice edges. Sometimes for things far away, we would just use cards because the parallax, the perspective shift in them wasn't big enough that you could see it. But if you would do that with something close, for example, that car, your hood all of a sudden wouldn't line up again because there's too much depth in it that it wouldn't line up. Using that step of projection was also where we stabilized all our footage. We basically took out the rotations out of our virtual camera and had everything stabilized automatically. Working with this, that was, as Gawain said, about almost 2 years ago now, and there was no VR tools at all available. We started building some of our own, but also found limitations everywhere and basically broke a lot of things. I'm sure the Foundry had a spam folder for my emails. So we had to improve some trigonometry functions because obviously the spherical stuff is based very much on trigonometrical functions, and at the top and bottom, if you have slight deviations, that shows quite a lot. As we wanted to project everything, we first had an approach of projecting cubic maps, so 6 cameras that project rectilinear images. That was way too slow, and we quickly realized we needed to speed it up, otherwise we would probably still be working on it. So we wrote our own spherical projection that was based on a basically a pixel shader using a world position path to project spherically, which worked really well. Also, the spherical renderer, as Mariana mentioned in the scanline render, was incorrect at top and bottom, so we actually ended up rendering 6 packs, which added then a filter hit, which going through all these different transforms, we realized we were collecting filter hits everywhere. So going down the pipe, our footage was degraded quite significantly. And to avoid that, we came up with a poor man's concatenation. We just piped an ST map through from the very top of our pipe to the very bottom. So all the transforms were applied to the ST map, and then we would apply that ST map to our initial footage and would only get one filter hit, which was quite a significant difference in sharpness. And then, obviously, a bunch of things, just working with spherical format for compositing. Roto shapes, quite hard, they don't wrap around the edges. Filtering is an issue. If you have a 1 pixel blur in the center, it should be at 4K, a 4K white blur at your last and first top and bottom pixel, because those pixels are just your poles. So it's one point that gets stretched over the whole width of the image. So any filtering needs to take that into account. So we had to come up with our own filtering tools, but now that's solved in the VR toolset from the Foundry. We also had quick ways of jumping in and out from lat long to rectilinear, the way the side and reproject now work, which also allowed us to quickly check everything within that rectilinear crop the way we would see it in the final output. So that was really important to always check it the way you're going to see it, because if you look at that lat long, straight lines aren't straight. So you quickly think, oh yeah, that's going to work, that looks pretty good. But then when you look at it in your rectilinear crop, everything is wobbly. So it took quite a lot of effort and learning from all our comp artists. But they did an amazing job at getting used to this, and with a lot of diligent work and watching out for all these roto shapes and issues like that, we were able to finish a pretty cool project. Looking forward, I think we're looking into other formats, working in an actual spherical space instead of working in a 2D space. That is definitely more of a research topic, but I think that's something we need to move towards if we want to keep working in this, is work in an actual spherical format and then just apply all your transforms from within a rectilinear view. And yeah, let's head it back over. We ran out of time, okay. Do you still want to say a few words?
Take any questions on that?
You reminded me of when they used to use multi-plane film cameras to shoot 2D animation.
Okay.
And often when we were doing post-process, we had to align the two worlds, the practical world, and using spherical tools to record the actual lighting on set or in a 2D space with the still animation, versus doing post-process matching the lighting or creating the lighting from scratch. So my question is, as far as lighting, did you have pure lighting on set, or was it practical lighting to record the information you needed, and then the cinematography, the aesthetic lighting applied as a post-process?
It's a great question. I would say it's a combination. We had those really high-level DPs, so we wanted to respect the lighting that they put down. We had a lot of conversations with them, and they really grasped what they were doing. Like they, particularly guys like Claudio Moran, who's at that forefront of like technical DP. He got what he needed to do, and he realized like, okay, camera shadows are such an issue that I'm going to really have to make my lighting work for this scene, but still give it a high-quality flavor and still line up as our our characters run around the camera, that there's key moments where they have those key moments where they're presenting a major line or a major moment. They are rim-lit beautifully, or they have the right fill light to them. So we structured it in that way. So we respected that, as we took over so much of the environment around the characters from shooting on blue screen, there was a process where we knew exactly which real-world locations in LA we were duplicating in CG, even though we can move them around. So we went out and we did a lot of shoots on those locations and then recorded that lighting. And it was really an amalgamation of that set lighting, that real-world lighting that we went out and studied on practical locations, and then over the duration of the project, an artistic interpretation of that. So as we worked into it more and more, we start to get that idea of like, all right, this works here, but to, say the end scene where we have these huge helicopters flying around and they're spotlighting them as they run out into the LA River. Where those spotlights coming from casts really directional shadows, but at the same time, we need the helicopter to be in a certain place so it can fire a missile at the monster, and that all needs to be orchestrated. So it's a combination of the three: respecting what the DPs lay down on set, respecting the real-world environment, and then a slight artistic tweak over the top. If that answers your question. Am I out of time? Can I take one more?
One more.
So you said at the beginning that your initial requirements were a perfectly stitched 4K deliverable in monoscopic.
Yes.
But then it sounds like over the process, you kind of ended up in a 3D space one way or another.
Yep.
So then I would imagine there was a conversation at some point that was like, hey, maybe we can do this in stereo, actually.
We have had that conversation a lot. And from that, I've done a lot of research into the whole stereoscopic issue for VR. I think people's understanding of stereoscopic in VR is probably simplistic at the moment. That if the whole film industry has abandoned filming stereoscopic, not that they don't release stereoscopic, and I really like stereoscopic films, but they've abandoned filming it and they all do it as a post-process so that they have that fidelity and that control over the stereoscopic environment and the separation. Then surely just strapping 2 cameras in every direction and filming is a highly naive approach. I think lat longs are going to continue to struggle to hold all that data for stereoscopic. So at the moment, we've looked at it a bunch, and I'd love to do a post-stereoscopic conversion of some of this media and play around with it more. We've looked at it in the office, but to do it at a quality that matches the quality of the film, I think would be a really big undertaking, and you run the risk of, if it's done poorly, you're going to detract from the media, that people are going to be watching it and they're going to be suffering from that poor stereoscopic conversion and not just enjoying the film. Thank you very much.
So thank you very much. That was very informative. So next up is Justin Lin, head of CG and Visual Effects Supervisor with MPC in LA. One of his main projects has been the Goosebumps Vr project, which is a stereoscopic. It was for a special venue experience, and they put it in different lobbies around the U.S. To tie into Sony's feature film. So with that, I'll turn it over to you.
Thank you, Scott. Thanks, everyone, for coming out this morning. Hello, I'm Justin Lin. I'm head of the 3D department here in Santa Monica. I'm here to talk about Goosebumps VR. This is a project we worked on last summer with Sony Pictures for a promotional piece starring Jack Black. This is a linear 2K story, stereoscopic movie played in the Samsung Gear VR and through our custom movie player with MPC. Before we really get into this, let's watch the piece captured through a VR experience.
Are you okay? I don't know what we just hit. It came out of nowhere. Is there something behind us? Good. What is that? Oh, I don't remember writing about a giant praying mantis. Oh, right. Now I remember. Hang on. Hey, you! No, don't look at me! Keep your eye on the giant bug! They've all turned against me. It's like Frankenstein's monster turning on Frankenstein. It's not natural. It's amplified. It's amplified! Where is it? Do you see it? Oh, no. Oh, no! It's right above us! Oh, we could have bumped into any of my monsters. The long nose, the haunted mask, a really slow walking mummy. But no! It had to be that 60-foot tall bug! Look out the back. Is it still behind us? Hang on, I'm gonna try and lose it! We did it. It's gone. We're safe. Oh no, we're not. Look out there! It's over, can't you tell? No, no twosies. You don't stay on for a free ride. No, that's it. Go, go. Back to the end of the line if you want to know. Go!
All right, that one was a lot of fun. We worked on that over a couple months, August, September, October, released out to just in front of the movie. This showed in front of 15 different locations as a promotional piece. So along with director Rob Letterman, the idea was to take the scene from the Goosebumps movie and create a 90-second VR experience that you're sitting along Jack Black, trying to escape from a 60-foot giant praying mantis. NBC Film had done the effects on the movie, and the director wanted the same exact quality that he had gotten in the movie from NBC in Vancouver. See, our first thought was to shoot Jack from a passenger seat using a full 360-degree camera stereo rig, and that would be in front of a green screen. We would shoot matching plates driving through a town and then composite the car over the mantis and the practical city streets. This is exactly how the film had done the movie effects. This was problematic, however, because we had just shot a 360 mono piece earlier, and we knew anything closer than 3 feet on a mono camera rig becomes very difficult to stitch, as you've heard. There's lots of parallax problems. You can see here on the very top, this is just a few inches away, the difference between the two cameras. The far background becomes, when you get the far background to work, the plant doesn't stitch, and when you can get the plant to stitch, the far background doesn't work. This is inherent, and as soon as you would do this inside of a car, you had the same issue. The seats and the dashboard, anything close would not work. We tested several 360 camera rigs and found that shooting a spherical 360 experience with action cameras would be limiting due to the size of the rig and the close proximity of the interior of the passengers. Adding a binocular stereo component to a full 360 rig would have been additional stitching errors that would have been difficult to resolve in both eyes, and ultimately would have been throwing away most of the footage. Because of this, we decided to treat Jack Black as a stereo slice, placed inside of a 3D vehicle traveling through an entire CG city. The hybrid approach has allowed us further control over a spatial relationship between the viewer POV, the car, and the performer. So basically, we're using him as a card, shooting a stereo image, and placing him in there. This way, we're not having to deal with any of the stitching issues. We shot several tests. Our first test was with the Red Epic, with a couple of different issues. First, the bodies were so wide that we had to shoot on a stereoscopic mirror rig. But because of that, we had to be positioned so close in the seat next to Jack that we had to be on a very wide lens. The lens had to be so wide that we began to see the mirror rig, which blocked the view of our driver. Additionally, the wide aperture and large film back rendered a beautifully shallow depth of field. But unfortunately, that was not what we wanted. We wanted everything to be in sharp focus, just like the CG camera. Eventually, we settled on the Kodak's Action Cam using 5mm Kona lenses. They were 2/3 sensors, shot in full HD, and didn't have any of the rolling shutter issues. Nice little cameras. They both work. They both read into the Kodak's recorder. We decided to shoot the camera in portrait mode to maximize the frame, and planned to shoot 2 cameras placed at 6.5 centimeters apart, a common interpupillary distance. As a safety measure, we placed 2 additional cameras on the outside of our stereo left and stereo right for coverage, in case Jack gestures broke outside of our frame of our primary cameras. We knew we only had 2 or 3 hours with Jack on the set that day, so we were very aware that he's a very physical performer. Since this was his first virtual reality shoot, our goal was to set up a shooting scenario that would allow him to perform, and we wouldn't be burdened by technical limitations. The creative success of the experience largely depended on the creative feeling that we were sitting next to, creating a feeling that we're sitting next to a movie star in a scene from his own movie. We had a pre-late day to make sure the equipment was working, but Jack would learn his lines that morning and ultimately shape the performance by bringing his own character to it. We planned to shoot Jack in a practical Jeep Wagoneer in front of a green screen on stage. We only planned to keep the parts of the car that we needed and use the rest as reference for our CG Wagoneer, which really meant whenever he was touching the seat, where we tried to use those shadows as much as we could, and we mainly grabbed the entire steering wheel and bits of the floor. The rest was completely CG. The next challenge was to make Jack feel like he was moving through the environment and not sitting on stage with static lights on him. We decided that we would build a previs for timings, render that through a spherical camera, and then play back on 4 large LED screens that would cast the appropriate light on Jack. This meant we had to go get our previs approved prior to the shoot, which meant we had to build and lock the entire city layout with rough blocking of the Mantis animation prior to the shoot. So we took all the relevant assets from the movie, which included 60-foot Mantis, tracking model from the town they shot in, and HDRIs that were shot from the center of each block at town at night from the film production. From that, we did a digital recce with Google Maps and determined the best path through the town that was appropriate amount of fun twists and turns to get us to drive past the town hall so that the Mantis could crash into it, as it did in the movie. Our first path through the city timed out to be 90 seconds, but unfortunately the real city blocks were too small and made us drive really slow. We had to remodel the city, duplicating the best sections of the city in the most detail, but carefully so that we didn't make the city scene repeated. Our new city was double the size, with each street twice as long to drive down, which meant we were now driving twice as fast, which made it twice as exciting. Great. Prevising in 360 was another challenge. Let's turn that a bit. There we go. Go back. We'll play. Maybe not. Okay. Prevising in 360 was another challenge. It would be too easy if all the animation occurred in front of us, but our director, Rob Lemons, specifically wanted to direct the viewer around by having Jack say, "Look behind us. Where is he? Is he above us? Oh no, look over there." This meant we had to previs the sequence multiple cameras, and we had to have a way to review them together. This meant the previs. This was a bit of a challenge, and we had to use several wide angles that were composited together in a picture-in-picture style. I think this is all a part of the review process. We're still discovering how to use this footage. Later, we discovered there's a cool tool in RV, thanks to our friends at the Mill, that we eventually wound up using a 6-pack rendering system and then reviewing that in Nuke inside the plugin for the lat long viewer. This lets us review through a virtual camera just like you would in YouTube 360. So just a quick little note, popping down, you can load that package inside of RV. It's available in the latest version. So now that we got the previews approved, Then we created a rough lighting pass that could be displayed on the panels on set. Ideally, this is where Jack would come in, learn his lines, and react to the monitors around him for the mantis, and know as well when to turn the car. In reality, it was a bit optimistic to think that it would go that perfectly. Jack's timings creatively didn't sync up with our timings, and it was close enough that we wound up animating the car and the mantis to fit closer to what Jack was actually saying and doing. On set, we adjusted the panels to appear more contrasted, just so we could get more light movement on Jack. We worked closely with the director of photography to strike a balance of realistic light and additional lights to make sure Jack looked great. Since MPC Creative was running the production, it allowed us some extra freedom to experiment with untested technology for on-set capture. We used 2 time-of-flight sensors with running Breckle to capture per-frame geometry of Jack's performance. Basically Kinect sensors. This is something we wouldn't have been able to do if we weren't running the shoot. Later we took the geo and combined it together into a denoised, watertight mesh, and then rendered it through the final lighting scene to capture the CG lighting. That illumination was then multiplied into Jack's plate to make him feel like he was actually lit by the CG scene. Meanwhile, our new CG city layout was all gussied up with the projected spherical HDRIs from set. The projections were then cleaned up, color corrected, and then additional geometry was added where needed. The roads and sidewalks were traditionally textured and lit, and then littered with hundreds of cars, mailboxes, stop signs, and other street furniture. All CG trees and bushes near the road were lit and rendered, but the trees in the background were just CG 2D cards. The mantis had to match the quality of the film, but the original team that worked on the movie was in Vancouver at MPC. After sending an animation cache along with an animated HDRI to MPC Vancouver, they would render those caches in RenderMan and then send the images back to LA. In addition to the town hall destruction renders, they also sent footfall destruction caches that our LA effects team would then place and render in Mantra. So it was a big pipeline between the 2 facilities, and all those renders had to match up. In total, we had 4 different renderers that had to render pixel perfect. Arnold for our initial previs, V-Ray for the city and the car interior renders, RenderMan for the mantis renders, and finally Mantra for all the effects elements. We implemented the same slit scan stereo camera function in Mantra and RenderMan to match our V-Ray and Arnold renders. Okay, so just a little theory here and to talk about some technical bits about VR. Right now, VR covers a wide spectrum of experiences through the space. Advertisers in mind. Each experience has a limited audience, and just to focus on the linear moving experience part of that, some people consider YouTube 360 as VR, probably thanks to QuickTime VR, and is available to every person right now with a camera, with a computer or a smartphone. You can view through a magic window, and the sense of presence and immersion is fairly low. And you could do it, and it has to. I think that has to do with a lot with field of view. Right now, your view is barely filled up by the other world. Moving up just a little bit, we have Google Cardboard, which gives you a good sense of looking into another world. Now, most of your vision is covered by the goggles, but the field of view and the goggles in hand, the sense of presence is better, but you always feel like you're looking into a world but not necessarily immersed into it. Moving up again, Samsung Gear VR has more of a polished experience with the field of view at 96 degrees and is hands-free. It's significantly better and still mobile. It currently has the best nodal head tracking but doesn't have positional tracking, which means you look but you can't lean and you'll remain stationary with no parallax. The Oculus Rift and the HTC Vive are a big jump up, tracking both nodal and positional, offering a walk-around experience. This has a very high sense of presence and the ability to gain new perspectives on your environment. This, however, requires being tethered to a desktop computer to handle the processing you need to display in real time. So going to the camera, the devices that run real-time engine can render the correct stereoscopic view no matter what direction you turn your head. Devices that are playing back a stereoscopic movie, however, have to cheat. Rendering a 360 movie image from one point in space is pretty straightforward. It's one point and you can look all around. However, when you need to render two images for a stereoscopic left and right eye, you can't just render them from two individual points in space where your eyes are. Because when you look left, you're looking into your other eye, and when you look right, you're looking into your other eye. And when you look behind you, your vision is reversed. The answer is to render omni-stereo panoramic images. Omni-stereo can be constructed by mosaicing together images from rotating stereo pair. Like two slit-scan cameras rotating around a shared axis, this means when your head is facing a particular direction, only the center row of that vertical pixel is technically correct from your head direction. And as your eyes travel farther left or right, they become mildly inaccurate. This is much more obvious when you look straight up or down and try and resolve those stereo images. So how does that relate? This is going back to how we rendered our piece in Google VR, Goosebumps VR. We had this very same issue. We were using a stereoscopic view inside Gear VR. As one of the many on-the-fly decisions you make on set, we decided to move the action camera rig back about 12 inches because Jack kept moving outside of the frame. Even though we had extended view cameras, the call was made to avoid as many stereoscopic repairs as possible. When we dropped him into the comp, it was apparent that that he was shot with the wrong perspective and we would need to fix it. Ocula to the rescue. Pretty cool stuff. Yay. So this is also back when a lot of these tools weren't available, but we're definitely excited about the new stuff that's coming through. Since we're keeping the practical steering wheel in Jack's hands, it was really apparent when the perspective was off. So using a few tools here, we used the Oculus's O-Solver, disparity generator, and the axial shifter to save the day. What it allowed us to do was fix the perspective of the plate, so it looked correct. This is not light field, but it's probably the next best thing. Now, the potential here is pretty amazing. What you can see is if you started a nodal stitch, a 360-degree camera, you can invent new camera views, effectively creating an omni-stereo panoramic images from a single view. Now, I think everybody's been trying to build a nodal rig and using it just as trying to create a perfect stitch pair. However, there's other cameras out there coming soon that are embracing the offset, the parallax that we're getting between all these different cameras. And the idea is to get more views of the same object in the scene. This would effectively allow you to build a 3D representation of that scene and render cameras where you needed to, as we did with the panoramic omni-stereo image. All right, so I'm not sure if you noticed, this is also going on to some other what-ifs. I'm not sure if you noticed that there was, in the previs, there was two people sitting in the back seat. But in the original brief, they were meant to have two kids riding along. We were planning on treating them just the same as Jack, with the 2D elements as a 2D element in a 3D world. But we were concerned a little bit about getting them to sync up with what Jack was doing, because we were intending to shoot them at different times just to try and get the perspective correct. We wouldn't be able to have the rigs on top of each other. In the end, it didn't work out because of the schedules, but we had a few ideas and we wanted to try. Since the video is running through our custom app, this affords us a lot of cool ideas we could do. For example, we could really switch out video. When you're looking at Jack, the kids' video or audio gets switched to something else, and then when you look at the kids, you can switch out to his video. So one single experience can have multiple different threads through through this environment. It actually offers a lot of repeat views. I think there's a lot of these storytelling techniques and options that we haven't really explored in this space. Audio plays a huge part in the immersion experience. E2 recorded binaural audio on set and created spatial audio track. They then wrote out 4 stereo audio tracks that were loaded into MPC's VR player. And when you looked directly at Jack, you heard the sound that was coming straight from him. And when you looked over at the Mantis, you could hear the audio from his footfalls coming from the correct location. Another aspect of this, MPC loaded the 30 headsets with the Goosebumps VR app and performed rigorous tests on and QCing for the memory leaks and other bugs before releasing to the 15 locations around the world. And so, yeah. I think this is another aspect, though. It's the first time that I've ever had to do a full release product outside in the wild. I mean, it's really, a lot of this has to do with game development, and from a VFX perspective, I'm used to VFX pipeline. We're delivering a single product, and that's it. So it's really, VR is offering up a whole lot of new exciting opportunities and branching out. Another really cool aspect of the Goosebumps VR experience is we work with D-Box. So D-Box makes motion graphics chairs and motion chairs, and they tilt and move and shake when you're watching. So those chairs are a perfect match for a driving experience as you feel the car weave and through the legs of the Mantis.
You look like you're totally there, like right now.
Oh, that was easy.
Yeah.
Boom.
All right. So in conclusion, I'd like to say Jack Black is awesome. I hope to have you in. I hope you get to have him in your VR experience. If you don't, then go check him out in the Goosebumps Gear VR headset near you. Out in the line. Thanks. I'd like to open up to any questions.
How much of the stuff you could capture through Breckle did you use versus the disparity, versus the geometry you created through the disparity?
We shot the Breckle stuff as a big what if and a safety. We had other, I didn't mention GoPro cameras, but we had also shot witness cameras just in case we had to do match move. We weren't really certain how much trouble we were going to get in if we moved the camera too far off of where it was going to be. So in the back of my head, we were thinking we might have to reproject and re-render his position. In the end, the Breckle stuff wound up being really, really noisy, and you can see it. But I thought what worked well is we just smooth it into a nice little lump, and when we ran through the lighting, you could actually see the lighting travel across them. And that was enough to give a sense. It was actually probably closer. It was probably closer of a lighting match than what we had with the intended with the monitors on set. I mean, there was an overall, like the monitors on set was a nice idea, and I don't think it worked practically. It just gave them a good motion. In my mind, it was going to be pretty well timed, and we'd get the Mantis being over there. But in the end, I think it's the Breckle stuff had more of a contribution to what the CG looked like.
What's the focal length on the Codex cameras? Those rectilinear lenses?
They're solving close to 90 or 100. I believe. I'm not totally certain on that, but they're 5mm and 2/3 sensors, so fairly straightforward to calculate. We had used them on a previous project for a Camaro job, and I think it hadn't been a great experience on that one, only because we had 17 of those cameras, and that meant for each 2 cameras you had a little codex recorder, and that was like 17 points of failure. So we did spend half our day trying to get all that working out, but when we went down to 4 cameras, we had no problems with it, the shoot here. Yes?
How much time did you allocate to post, and did you have to expand the team or schedule to meet your release date?
It was a really small team and a fairly small schedule. We shot and delivered within 3 months, I believe. So there was about 5 or 6 people on the team. It was fairly small crew. Anybody else? All right. Well, thank you very much.